Okay, so hello and welcome to the ongoing walkthrough series, and in this episode we are looking at 9618 variant 42 of October November 2023, and we will be doing the Python solution to question 1 of this paper. All right, so let's go ahead and look at the question right here. So we are given one source file that is going to be used to answer question 1, and it's called stackdata.txt. But what I did for my text file is that I had another stack data file that is from another question paper, different question paper altogether. So apparently the data is different from what we have going on inside the stack data for this particular paper, right? So what I did was to rename the file to stackdata n23.txt. So this is the file that we need to be working with, right? It is just a bunch of letters, I think about 100 something, actually 100 entries in it. So I just renamed the file so that it won't conflict with an already existing file, as it were. All right, so we are to create, we are to write a program to declare two 1D global arrays, one called stack vowel and one called stack consonant. And also each one of these arrays is supposed to be able to store up to 100 letters. And then of course they're just telling us that the first index element is going to be 0, but then again that's not really something that you should worry about, because already you know that Python is 0 index based, as it were, when it comes to lists in Python. So let's go ahead and look at the implementation going on here. So you see that I have two on lines 4 and 5, I'm declaring two global variables, rather they are lists, as it were, because the equivalent of an array in Python, you can just use a list. So we have two lists going on, stack vowel and stack consonant, and you see that we are initializing them with values of none. None simply means that they are null, or there's nothing inside of the array elements, and we are multiplying that by 100, because that's how you can instantiate a list that's going to store 100 elements in Python. So we are doing this for both arrays, stack vowel and stack consonant, as it were. Then moving on to the next part of the question, item number 2, we are required to also have a stack pointer, right? And the name that you are going to use for this one is called the vowel top, and basically it's going to point to the top of the stack vowel stack, and you also are going to have another pointer called consonant top, and it's going to point to the respective pointer, as it were. Then of course both of these pointers should be initialized to 0, and yeah, they should be global again. So let's go ahead and look at the implementation going on here on line 7. You see that we have the two variables, vowel top and consonant top, both initialized to 0. Moving on with the solution, let's go ahead and look at part B, item 1. So the procedure push data takes one letter as a parameter, and if the parameter is a vowel, it is pushed onto stack vowel and the relevant pointer is updated. If the stack is full, a suitable message is output. If the parameter is a consonant, it is pushed onto stack consonant and the relevant pointer updated. If the stack is full, a suitable message is output. You do not need to validate the parameter in a letter. So we have to write program code for the push data function, as it were. So let's go ahead and look at the implementation that I've put on here. So you see that we have the push data function declaration on line 18 there. Then of course it's going to take a letter. So what I have going on here, you might have seen this in my other videos, right, in Python. So if you come here, you see that in Python, if you are using Python, you are supposed to basically comment out most of the things that you're going to be doing, so that you document what you're doing. Let me see if I can find that command right there, that instruction. It's gotta be somewhere on the paper. Right. Okay. So if you can see it right here. If you are writing Python, include declarations and declarations using comments. So you should describe, let's say, for instance, here, you're supposed to describe that these are vowel top and consonant top pointers to the respective what arrays. So something like this is required for you to actually conform or follow along with what they are saying, is it? So we can call this one point at the top of the stack, right? And then we can also do the same for this one, so that we can just go ahead and copy and paste it here. Right, so console and stack, then this one is the vowel stack, as it were. Alright, so the whole idea that I want to demonstrate here is this colon string, colon str that I have going on there. So basically, this is just a way to avoid having to comment everything out in Python. So essentially, you're just telling that, you're just saying that you're just telling the interpreter that this function called push data is going to take a letter as a parameter, and the letter should be a string. So that's what it is actually, this is what this str, colon str means right there. You're just telling the interpreter that this function is going to take a string as a parameter, and it's also going to help whoever is going to be reading your code to know that it's going to expect a letter as a string. Then later on, I'll show you how you can indicate that a function returns a particular data type, like I did in this helper function there. But anyway, just to do the implementation for the push data function, so you have to use the global keyword so that the function knows that we are referring to these global variables right here, line 7 and 8. So that's what we are doing, global vowel top and global, consonant top. Then if is letter, rather if is vowel, right, then we are taking the letter as a parameter there. So this is vowel method. I actually declared it right there on line 13 and 14. It's a helper function. It's not required and it's not mentioned anywhere in the paper, but I did include it here so that I would have to avoid to validate if something is a letter inside of this push data method, is it, so that I can just use the helper method right here. So essentially, let me just walk you through the helper method. So its vowel is going to take a character represented by C of type string, then it's going to return a boolean. So this is what this notation means. This hyphen and right angle bracket simply means that it's going to return a boolean, as it were. Then we are simply going to return the character. We are simply going to return true or false, is it? So this particular portion that I've highlighted here, this particular segment of code, is actually going to test to see if that character that was supplied as an argument, or the parameter that was supplied as an argument, is inside of the A, E, I, O, U, which are the 5 vowels that we have going on. So if it's inside of here, then it's going to return true. Otherwise, it's going to return false. So this is what this is vowel function does. So it's going to return a boolean true or false. So here we are just checking to see if it is true. If the letter that was supplied is actually a vowel, then we are simply going to try and push it onto the top, onto the stack if we have space. Then if we don't have space, we are going to output that the vowel stack is full. So the way we are going to check that if there is space is that we are going to take the vowel top function, variable, the value that is stored inside of the vowel top variable. Then we check to see if it is less than the length of the stack vowel, as it were. So if it is less than the stack, then it simply means that we have space to push something onto the stack. So we are going to push the letter onto the stack right here on line 22. Then of course we are updating the value of vowel top on line 23. Otherwise, if there's no space, we just tell the user that there's no space. So we are doing the same thing for a consonant, right? Checking to see if consonant top is less than the length of the stack consonant, and if so, we are taking the letter and pushing it onto the stack consonant, updating the pointer. Otherwise, we're just telling the user that there's no space. So that's just about it for the push data function. Then of course you go ahead and copy the code and paste it inside of the evidence document. Then item number 2, we have the file stack data.txt, which stores 100 lowercase letters. Then the procedure read data reads each letter from the file and uses push data to push each letter onto its appropriate stack. Use appropriate exception handling if the file does not exist. So we have to write program code for the read data function. So let's go ahead and look at that going on here on lines 35 to 42. So we are opening the text data file right here. Remember, I called mine n23 at the end so that I can distinguish it from an already existing file, as it were. So we are opening it in read mode and we are calling it, giving it a label file. So we are going to iterate through the file each character. So if the current character is actually an alphabet character, right? So this is alpha. Function is actually built into Python, is it? So you can actually see that it's going to check if the string is alphabetic in all characters in the string, right? So that's what it does. So if you remember, they did say that we do not need to validate that the parameter is a letter, right? But we're actually just going to do it anyway because it's super easy to do. You just use the built-in is alpha function that is built inside of Python. Then of course we are simply going to take that character and push it onto the stack. Otherwise, if we have any problems opening the file, we are just calling the file not found class and creating an exception object. Then we just tell the user that we didn't find the file. We don't need to have print here because we don't have any don't have any variables that we are using here. So we are just outputting error, file not found. Then we are concatenating. We are basically converting the exception object into a string, so that is going to be concatenated right here when we output it. So let me just put a comma there. And then, yeah. So you, of course, go ahead and copy the code and paste it inside of the evidence document. Then we also have pop value and pop constant. So if you know anything about data structures, you know that pop is the way you remove elements from within a stack or from a stack, as it were. So pop value is supposed to remove from the vowels stack, and pop consonant is supposed to remove from the consonant stack. Then of course for both methods we need to write a message that there is no data right to pop. If should there be nothing, or should the stack be empty. So we have to implement this functionality for pop vowel and pop consonant. So you actually see that it's pretty much the same thing for both functions, right? The logic is the same. It's just that the identifiers for the functions are different. So again, this is a pop vowel method that's going to return a string. So remember, this is what this notation means. It's going to return a string. Then we are referring to the global variable vowel top, and we're checking to see if vowel top is equal to 0. Then it means we have no data. Otherwise, we are going to try and remove the element by first updating the vowel pointer or decrementing the vowel top pointer by 1, then simply taking the element that is on top of the stack vowel and returning it. So you're doing the same thing for the pop consonant. You actually see that it's exactly the same thing really. Then moving on to D, we have the program that needs to call read data. So you actually see that we have that going on as the first line inside of the main function there. Then you're going to prompt the user to input their choice of vowel or consonant, right? Take as input the user's choice. Depending on the user's choice, call pop vowel or pop consonant and store the returned value. The 3 steps are repeated until 5 letters have been successfully returned and restored. Returned and stored, rather, not restored. If either stack is empty at any stage, an appropriate message must be output. Once 5 letters have been successfully returned and stored, they are output on one line. For example, it's going to be something like this, is it? So let's actually go ahead and look at the implementation. Then maybe one thing that I want to point out for these questions, it's always a good idea to read the entire question so that you know you have the full knowledge of what's expected to you, right? So that you can plan ahead. Because if you were to read just line by line and try to implement it, you might actually find out later on when you've written a few lines of code that you need to repeat certain segments of the implementation. So it's always a good idea to read the whole thing first, and then come back and start implementing it once you have a full picture of what you're trying to accomplish. So obviously here we are going to repeat, so it means we need to have a loop. So that's why you see that I have this while loop going on. And remember, they said that we need to have 5 letters, so it means that this loop is supposed to run five times. So we are saying while result is less than 5, so the length of result, right? While the length of result is less than 5, right? So each time when we run currently result, the length is 0, so it's going to run from 0, 1, 2, 3, 4, which is 5 times basically. So we are prompting the user to enter a choice between a vowel or a consonant, and then we are stripping off any white spaces and converting to all lowercase. Then on line 69, we are moving on to use an if statement. Check to see if the choice is equal to vowel, right? If the choice matches the string vowel, in which case we are going to pop the letter from the vowel stack. Otherwise, if it is consonant, we are going to pop from the consonant stack. Should the user not type vowel or consonant, we are simply going to output invalid choice, is it? And the loop is simply going to continue. So the user is going to stay inside of the loop until they choose a valid option. That is, they type either vowel or consonant. Then on line 77, should the letter be empty, then it means we are going to print that the stack is empty. Then we can specify the choice, right? Then should the letter have something or store something or return something, as it were, according to line 70 and 72, then you're simply going to take this result right here. So remember, result is a list right there on line 66. So you're simply going to append the letter to the result list, as it were. Then after which, when the loop is exhausted, we go outside of the loop. Then we just want to output the string is indicated right here. Is it that after 5 letters have been successfully returned and stored, we need to output them on one line, like something like in this case. So we are simply taking the elements inside of the result list and using the join method. So the join method basically concatenates everything that is inside of the list, as it were, and we are just outputting that the result is. Then you call the join method, the join function on the result list, as it were. Then of course we are calling main on line 85 and 86. Moving on to ID item 2, we are now to test our program with vowel, consonant, consonant, vowel, vowel. Is it so? We have vowel, consonant, consonant, vowel, vowel. So let me just come here, make sure that I've saved my file and click on the play button here. All right, so you see that it's asking us to enter a choice. So we know that we are supposed to enter vowel first, then consonant, then consonant again, then vowel, then vowel again. So you see that our result is this UTXOE, is it? So this is what the function, or rather the program, outputs in the end. Then of course you would go ahead and take a screenshot of the output and paste it inside of the evidence document, and as it happens, that's the end of the Python solution to question 1 of this paper. So hopefully you learned something, and I'll see you guys in the next one.